Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. And we'll take as many audience questions as we can before the end of today's webinar. And finally, at the end of today's webinar, we are going to be doing a drawing for 3 $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our big winners. Okay, with that, we'll go ahead and kick off today's webinar, which is Bridging the Security Testing Gap in Your CI/CD Pipeline. Our speakers today are Kim Yo, who is Senior Product Marketing Manager, and Asma Zubair, who is also Senior Product Manager. And I would like to welcome both ladies to our webinar today. So welcome, and Kim, I know you are going to be kicking off today's presentation, so I'll just put myself on mute, let you get to it.
All right, thank you very much, and a very good day to everyone. For today, we are very happy to be here to share with you some of the challenges in the app security space, especially pertaining to how is it being used and run as part of the CI/CD today. My colleague will be sharing with you more on Synopsys tool, Seeker, and show you a live demo following that. With that, let us get started here. So today, over 94% reported the pace of innovation within their organization has accelerated significantly in the last 3 years. I'm sure every one of you here in the audience have gone through some form of transformation within your organization. This was from an annual study conducted by Accenture with 6,000 executives this year. More businesses have completed their digital transformation than ever before, leveraging technologies such as mobile, cloud, IoT, container, and so on. Businesses in industries such as finance, retail, technology, most of the industries here, they have crossed the chasm with regards to technology transformation and DevOps. And we are all seeing an increase in frequency in code deployment and releases with faster mean time to resolution. While all these are great, one area is still lagging in this whole transformation, and that is security. In fact, cybersecurity is one of the top 5 executive visions for the next 3 years, according to this Accenture study. As the digital transformation becomes the new norm and companies converge on the same digital footing, we find more digital ecosystem built between the businesses and their partners to create the holistic user experience. This has resulted in increased complexity and risk in delivering apps that are both fast and secure. If you look at the digital ecosystem today, security threat actors, they have unlimited point of entries to an enterprise. The attack surface includes not only the target company, but every partner, every vendors in the supply chain. How do you ensure that your third-party vendors, partner systems, which are connected to your systems, are as secured? How do you minimize the attack surface in the complex ecosystem today? There is definitely a heightened awareness and realization that enterprises who are not properly securing their apps are not just potential victims themselves, but they can also be someone else's vector as well. This is why every day we see companies making security headlines, either from their own flaws or through their digital ecosystem partners. Since 2005, over 11 billion records have been breached in US. This was from the number of data breaches reported to privacyrights.org and this number has been climbing rapidly in the last few years. Digital mobile and web apps continue to be the number one weakest link when it comes to breaches. Synopsys, together with Ponemon Institute, has recently conducted an independent survey of current security practices in the financial industry. The study found that over 76% respondents specified that it was difficult to detect security vulnerabilities in their software systems before release. A same number of people also responded and has concern that the cybersecurity posture of financial software systems supplied by their third party, and they're worried about the vulnerability introduced by third parties. Only 23% perform security assessments of these third party directly. Most organizations do not have established process for how they inventory and manage use of open source and third party components. And to add on to the complexity, there is a lack of skilled resources, with 62% said their organization does not have the necessary cybersecurity skills in product development, nor the time for security testing. If you're interested in more of these findings, feel free to download the report, which is available on our Synopsys website. So while these are current concerns and challenges specific to the financial industry, it does not mean there aren't any security strategy or tools in place. I'm sure everybody on the call here today, your organization would be using some form of tools and strategy within the organization. This is a study that was done with the DevSecOps audience, carried out by 451 Research a year ago. What they found out was that those who have adopted DevOps or have CI/CD implementation, penetration testing, software composition analysis, dynamic and static scanning are critical testing components to add to the CI/CD workflow. In general, it is a good AppSec best practice to use a combination of these tools. However, when any of the tools used in isolation, they will only find a subset of the total vulnerability present in a given app. To understand this better, let's take a look at the software development lifecycle. So if you take a look at the SDLC, on the far left, during early design and development phases, tools that we commonly use, such as SAST, static AppSec, software composition analysis, they are all great in detecting vulnerability statically during source code and build level. However, there is no way to catch these critical vulnerabilities that may surface during the app runtime. On the other end of the spectrum, DAST, dynamic scanning, and pen testing can find vulnerabilities during app under test. However, these are typically done later in the SDLC. Also, the detected vulnerabilities require additional time and expert resources to troubleshoot and verify if they're real and exploitable. Trying to fix these flaws when the software is already built and deployed into production is also very costly and counterproductive. So as you can see here, in this standard SDLC, most security testing tools are focused at either the central build, unit testing, or production deployment phases, with multiple teams using different tools and separate dashboards to keep track of the testing and risk across the enterprise. There is really a lack of consistent security test coverage from app integration through to production deployment, one that enables continuous application runtime security testing and the ability to catch vulnerability early in the CI/CD process. In fact, these are some of the key challenges found when surveyed with the DevSecOps audience. Making on the top of the list, some of the security challenges found include lack of automation and integration of the disparate tools, inconsistent approaches used, as well as a high false positives generated, which further slows down critical development and security work. So the key question is, How do we maximize application security and development velocity? How do we integrate and automate dynamic security testing into our CI/CD? Most importantly, how do we identify and prioritize critical vulnerabilities that will help minimize development teams' effort in triaging and remediation? And this is where IAST comes in. IAST stands for Interactive Application Security Testing, and it is a next generation solution that can help build in continuous security testing in your CI/CD. As you can see here, there are multiple tests carried out by different teams from build integration through to pre-production releases. They include functional, non-functional tests such as load performance and regression testing happening concurrently. It is therefore very difficult to trace and track consistently some of the real and critical vulnerabilities that only occur during this runtime. IAST bridges this gap and helps teams automate security testing of their web applications in the background while the teams carry out their usual functional or test automation. There's really no extra security scan or steps needed. The way it works is IAST leverages instrumentation technology for the runtime security monitoring and detection. If you know instrumentation, it is not a new technology. It has been commonly used in application performance monitoring and other areas of software, including container monitoring and analytics today. IAST analyzes code execution using the runtime monitors, and it provides both security and development teams visibility into the executed code and runtime data, from HTTP request and response down to the line of code in their source. It also provides visibility into potential exploits coming from the database calls, file system calls, web services, and string manipulation, among others. So as I mentioned earlier, there is really no one-size-glove that fits all when it comes to application security. It really depends upon the business objectives, the organization's security adoption and maturity journey. You may need to use a combination of these tools. Here, what we have is breaking down to you the difference between the static tool, interactive tool, and dynamic. Generally, static SAST tool is used in development, and it is good for early detection of bugs in the source code. It is very easy for developers to use as they can help pinpoint down to the line of code, and they can fix it very quickly in the IDE. Today, most of the SAST tools can be easily integrated in CI/CD. The only drawback here is that it provides limited vulnerability context, as there are no runtime information available to validate the fixes, nor its recurrence later during runtime. DAST, which stands for Dynamic Security Testing, on the other end, typically is used in QA in production. It can find runtime vulnerability, and you don't really need the source code or test suites to perform the test. Because it performs more as a black box testing, the drawback here is that it doesn't provide the line of code details needed for analysis. It requires additional security scans and cycles to analyze and triage. According to a recent study by NIST, the National Security Database, they have shown that it is 6 times more costly to fix vulnerability in production versus early in SDLC. So for businesses who are looking to improve process and cost efficiency, IAST can be a great supplement and alternative to the current dynamic testing use. IAST is used in integration and testing phases. It is compatible with the modern apps and API that are built on top of the complex frameworks. All you need is a functional application, some test suites, and you can have the IAST agents instrumented to as many target apps that you want to test. It will automatically detect and map the client traffic to the functionality, parse data out of the complex data structure like XML, JSON, and verify that these detected vulnerabilities are real. With that, I will turn this over to Asma to talk about Seeker Interactive Application Security Tool and show how it works in a CI/CD setting.
Thank you, Kim. Good day, everyone. Thank you for joining. My name is Asma Zubair, and I'm going to talk about Seeker, our IAST tool. I'm waiting for, perfect. I got my control. Yeah. So before I go into details and demo, let me give you a quick overview of Seeker. Seeker is our interactive application security testing tool, and it performs security testing at runtime. You can use Seeker to perform security testing on web applications, web APIs or services, mobile application backends. And Seeker detects vulnerabilities in custom code as well as third-party code. Your application can be deployed anywhere. It can be on premises. It can be in the cloud. You may be using containerization for application deployment. So in all those scenarios, you should be able to use Seeker to perform security testing. Seeker can find pretty much all type of application security vulnerabilities. It tests for OWASP top 10. It will help you comply with 6.5 section of PCI DSS and so on. Remember the three top application security challenges Kim mentioned earlier? One of the concerns has been application security testing is not integrated or automated. Another concern is security testing slows things down. And the third one was high false positive rate. Well, Seeker addresses all those challenges very well. How? So first is Seeker offers automated deployment. You can install Seeker agent using the API during your CI/CD process. And with Seeker, you perform security testing during your functional testing phase. It essentially converts your QA team to security testing team, and you don't need a separate phase or a separate step for security testing. And Seeker automatically verifies vulnerabilities to minimize false positives. As a result, you can confidently push Seeker reported vulnerabilities to Jira or using Slack. Basically, you can send it directly to your developer. And Seeker is a tool that is very easy to use for DevOps, very easy to use for QA team, and very easy to use for developers. Now, let's see how Seeker works. To test applications with Seeker, you have to deploy Seeker agent wherever your application is running. And during the testing process, application will receive a request or a number of requests. And then agent starts tracking these requests. And based on application behavior, data flow, values in memory, Seeker analyzes all those things and reports vulnerabilities. Now contrast this behavior with DAST or SAST testing process. With Seeker, no more waiting period for application or source code scanning to complete. With Seeker, your security testing will not slow down your release cycle. Now, let's see. Some of you may already have a mature CI/CD process. Others may be working toward it. But the reality is pretty much everybody has DevOps and CI/CD in their plans. So basically, Seeker integrates very well in DevOps toolchain. Here is a very quick overview of what it means to integrate Seeker in DevOps toolchain. A typical workflow is like this. Developer commits the code, then a build is made, then application is deployed in test environment. And when you are integrating with Seeker, this is the point where you have to deploy Seeker agent. Wherever your application is being deployed, same place you put the Seeker agent. Then you go about running functional tests in usual manner. At the end of functional testing, you use Seeker APIs to pull vulnerability information. And depending on the type and count of vulnerabilities, you can give your build a pass or fail status. And Seeker reported vulnerabilities can be pushed into Jira, into Slack, or in emails. Now I'll take a moment to talk about some of the unique features that Seeker offers. Basically, Seeker is the only tool that verifies vulnerabilities automatically in real time. Result verification does not require any manual intervention and happens in the background. Contrast this behavior with manual verification process. Manual verification takes quite a bit of time and it requires expertise and knowledge of source code. I have seen situations where real vulnerabilities got lost in high volume of false positives. So false positives create a lot of problems. And that's why in Seeker, we have this unique method of verifying vulnerabilities using our patented technology to perform vuln verification at runtime to minimize false positives. Another interesting thing and very unique capability of feature is sensitive data tracking. Your applications are all about data. Some of the data that your applications deal with may be sensitive. So if you have a business critical application, it would most likely have some type of sensitive data. If your app does not handle this data appropriately, it may lead to sensitive data leakage, which may even lead to a breach. To help with that problem, Seeker has checkers implemented to report sensitive data leakage. These checkers report vulnerabilities when sensitive data leaks through log files or URLs or basically data being written in database in an unprotected manner. So this capability helps towards compliance with PCI, GDPR, and other such standards that care about sensitive data protection. Here is another thing. Most of your developers are not security experts. If you give them a list of vulnerabilities, they may not necessarily know how to fix them. More often than not, they won't even know how to fix them. So to solve that problem, Seeker has integrated eLearning in Seeker interface. What it does is developers can basically from vulnerability detail page can click on a link to learn more about a specific type of vulnerability that is there in the application. I will demonstrate all these capabilities, active verification, e-learning integration, and things like that in a few minutes. Here is yet another aspect of Seeker. Majority of code in modern applications is open source or third party. Third party or open source code increases speed and basically reduces time to market, enables developers to quickly build functionality, but it also introduces vulnerabilities and related risks. What Seeker has is integrated binary analysis powered by Black Duck to provide visibility into supply chain risks, to give you comprehensive bill of material consisting of information about vulnerable components and open source licenses. Now, let's look at Seeker in action. So what I have here is basically Seeker integrated in my Jenkins pipeline. In this pipeline, let me start a new run. In this pipeline, I basically get the code, then I build the application, basically webgoat application. I download Seeker agent, then I start the application with instrumentation turned on. Then I will run a few tests on the application, and depending on the count of vulnerabilities or type of vulnerabilities, I will give this build a pass or fail status. This will take a few minutes to run, so I will show you another run of this same pipeline. Here I am getting the source code. Here I am making a build. Then using Seeker APIs, I deploy the agent and I download the agent and unzip it. Then I deploy the application, just a few options at command line to specify to enable instrumentation. Then I run a few requests to the application, and in the end, I get vulnerability counts to give a build pass-fail status. Now you may say that you may basically not have all your applications in CI/CD environment. More often than not, it is a mixed environment. Some applications have continuous integration and continuous deployment, and others may be on a more traditional build process. On some applications, you may be performing manual testing, or you may have automated scripts to test the application, but you may not necessarily have a CI/CD pipeline. So basically, you should be able to use Seeker in all type of scenarios, whether you have CI/CD or not. And in that case, wherever your application is running, you just start the application with agent enabled, and then you just go about testing the application in standard process. So here I have instrumented webgoat running, and I will just run the application a little bit. And here I'm not exercising any knowledge of security. I am just exercising some parts of the application. And with this aspect, you will be able to see a bunch of vulnerabilities enabled, a bunch of vulnerabilities already reported here. And what happens is when vulnerabilities are reported at runtime, you can push these vulnerabilities into Slack or into email. And if your developers are listening to a Slack channel, they will be able to see this type of information in the Slack channel. And they can click on these links and get more information about vulnerabilities. For example, they can see where the vulnerability is, the URL information, the line of code information. They can see summary of vulnerability, exactly where in the code the vulnerability is, the data flow diagram from the URL request to how the request travels through the code and where the vulnerability is executed. And let's see what else. I will exercise webgoat a little bit more. as you can see, as I am exercising the application, I am getting more vulnerabilities. So that is the power of Seeker. You get the vulnerabilities at runtime with full context on vulnerabilities, source code information, and runtime context, complete information on the stack, on how data is being passed and how vulnerability is, basically where the sink of the vulnerability is. Not only that, as I mentioned earlier, you can also see comprehensive information about bill of material or vulnerable component information. So in this case, the project had total 118 components, and out of those, 17 components were vulnerable. And in those 17 components, there were about 85 vulnerabilities. Out of those 85 vulnerabilities, 2 were critical. Now, if you want to get more information, you can see what frameworks were vulnerable that are being used in the application and what vulnerability is there. You can even see CVE level information. Another interesting thing is compliance information. So what you can do is you can pick a project and go and look at the information about how application is compliant with various standards. Seeker provides compliance reports for OWASP Top 10, PCI DSS, CWE SAN standard, GDPR, CAPEC for attack pattern information. And you can simply click and drill down and get more information about various types of compliances, or you can even export the entire report into PDF. So that is a very, very quick demo. And actually, one more thing, earlier I mentioned that Seeker can find vulnerabilities in the entire stack, meaning in the custom code as well as third-party code. So what you can do is basically very easily filter information, filter vulnerabilities to see how many vulnerabilities are in your custom code and how many vulnerabilities are there in the third-party code. So this is a very, very quick overview of Seeker capabilities. And I hope that you enjoyed the demo and learned along the way. Very quickly, I would just again summarize Seeker's capabilities. It is designed for seamless integration in CI/CD pipeline. As I demonstrated, you can integrate it in CI/CD pipeline. You can integrate the output into Slack channel. You can push it into Jira, emails, and so on. And it provides compliance reports for various types of standards that you need to meet, that you need your applications to meet. Very unique capabilities in terms of sensitive data tracking, software composition analysis. Seeker enables your developers. It reports not only the vulnerabilities, but makes it easy and makes it possible to remediate these vulnerabilities easily through eLearning integration, through integrated notifications in developer toolchain and developer processes. And it is designed to scale. It easily scales because once you have put together a few lines of code to download the agent and to integrate it, deploy it with an application, you can use same process to deploy agent in any number of applications. So it is very easy to scale the instrumentation on number of applications. And regardless of your application security maturity, application security testing maturity process, you can and you should be able to use Seeker. Even if you do not have any security testing process, Seeker is a perfect tool to start automated application security testing program and doesn't require any security expertise. Similarly, if you don't have automated security testing process in place, and you can use Seeker to perform security testing during your functional testing phase, and that will help you cut down your pen testing resources and pen testing time and help you achieve better security posture through continuous security testing or a more frequent security testing process. And if you are high further along in your risk management maturity and you have a good fully functional mature CI/CD pipeline, you can integrate security testing process in your CI/CD pipeline using Seeker. So that is about it in terms of the presentation, and I'll hand it back to the moderator for questions.
Okay. Excellent. Well, we have a ton of questions that have come in so far, and I want to get to as many questions as we can. But before we do, just want to remind the audience, there's still time. If you've got a question that you want to ask, please just use your GoToWebinar control panel and submit your question. The first question here, what languages are supported?
Certainly. So Seeker supports Java and all JVM compliant languages, .NET, like C# and other .NET compliant languages, Node.js, PHP, and we are continuously and aggressively expanding language coverage. So stay tuned for more.
All right.
Usually on our website and datasheet, information is updated as new languages are added.
Okay, great. Next question, is Seeker open source?
No.
All right. Next question then, you mentioned data breaches earlier. How does Seeker track sensitive data and how is it different from other tools?
Certainly. So Seeker, as I mentioned earlier, is built on an agent-driven technology, and wherever the application is running, agent is loaded in the application's process to monitor the requests as they arrive, and as the data flows throughout the application, Seeker is able to monitor that. And if sensitive data comes in, Seeker has this automated intelligence, which is also configurable to identify whether application has sensitive data being processed. And based on that, agent knows what is happening to that data. Agent looks at the data, determines whether it's sensitive or not. If it determines that it is sensitive, it will track where that data is going. Is that data being written in a log file, or is it being written in a DB without proper encryption? Is it being exposed in a URL? And because it's an agent which is monitoring application behavior at runtime and is capable of watching what is happening to that data, it is able to determine accurately whether data is being leaked or not. How it is different? Several reasons. First is it is a runtime tool, so information is a lot more accurate. At runtime, we know we can apply patterns on the values to determine whether the data is sensitive or not. In traditional tools, for example, in SAST, if you have to do this type of check, you would base it by looking at the code and analyzing the code. You don't have information on runtime information, what the value is in a variable. In IAST, in Seeker, we have that information. Seeker agent is looking at data at runtime, so sensitive data tracking is a lot more accurate.
All right, great. Looks like we have time for one or two more questions here. Let's see, do we need to have a separate enterprise server set up for Seeker to be installed in Configure?
Yeah, so there are two components. One is agent. agent goes wherever application is running to monitor application behavior. The second component is Seeker Enterprise Server, and that is where agents send vulnerability information, and that is the place where you see consolidated vulnerability information. That is where you configure your projects and agents and so on. So yes, there are two components, Seeker Enterprise Server and agent. You need both. You deploy typically one enterprise server, and then you deploy agents wherever your applications are running.
Okay, great. Next question here. First of all, comment, very impressive. The question, who is responsible to write the test to run? Is it Seeker or the customer?
So tests are the responsibility of the customer or the application owner. They know their application the best. So they write their tests, and when they are running the tests, at that point, with the application, they deploy the agent. And this is a regular workflow as well, because whenever developers are writing code, this code won't go into production without testing and QA cycle. So it's a natural step to perform functional testing, and Seeker just piggybacks on that. When you are doing functional testing, at that point, you put the agent with your application, and agent will monitor the behavior and do the testing, do the security testing. So in short, application owner or the customer is responsible for writing tests and running those tests.
All right, great. Let's see, I think we have time for one more question here. How is this better than burp/Qualys?
So burp/Qualys, they are DAST tools. And if you remember, I think Kim also touched upon it. DAST is basically a black box testing. And over there, you have to set up scans to scan your application. So workflow is like this. You build your application, you test your application. Once functional testing is complete and you are ready to push your application into production, at that point you do DAST scanning. Since it is DAST scanning, that is one extra step you have to do. You have to configure DAST scans, you have to wait for DAST scans to complete, and so it takes more time. Overhead is high with DAST. Here, there is no such thing. While you are doing functional testing, security testing is getting done. So it saves you time. That's one. Second thing is, if you are trying to do security testing in your CI/CD process, usually the speed is the key. The velocity is the important parameter. And at that point, if you have to wait your CI/CD process for DAST scan to complete, that sort of defeats the purpose, in my opinion. So if you are trying to integrate security testing in CI/CD process, IAST or Seeker is the way to go. DAST is good for situations where you don't make builds, you don't have very regular updates to your application. Then once in a while, if you have to do it, you can manage with DAST. But if you have an active application where there is a lot of development is happening, DAST becomes an overhead, in my opinion. So that IAST is a newer technology, lower overhead, agent-driven, monitoring the application at runtime, more accurate results. Also, it has integrated, if you remember earlier, we talked about integrated, what was that? Software composition analysis or black duck binary analysis. You don't get that with DAST or Qualys or burp. So yeah, there are quite a few differences.
Okay, all right, great. Well, it looks like we have to close out the Q&A session at this point, but I do want to thank everybody who did submit a question. And if we didn't get to your question during today's webinar, please know that the folks at Synopsys will get a question or a copy of all the questions that come in, and I'm sure they'll be more than happy to follow up with you offline. Also, before we close things out, I do want to do the winners, the drawing for the winners of the three $50 Amazon gift cards. So without further ado, I will go ahead and do our drawing. Our first winner is Anthony Barnes. Congratulations, Anthony. Our second winner is, forgive me if I butcher your last name, Nishant Chogul, I think it is. Congratulations, Nishant. And our final winner today is Jean-Francois Bilodeau. So congratulations to all three of our winners today. Just a quick reminder that today's event has been recorded, so if you missed any or all of the event, you will have the ability to access it on demand. Even if you just want to listen to it again, you can do that also. We will be sending out an email that contains a link to access the webinar on demand. And the webinar is actually going to be living on the devops.com website as well, so you can always find it there. Just go to devops.com/webinars, look in the on-demand section, and it will be right there waiting for you. Kim and Ozma, thank you so much for giving such a great presentation today. For the amount of questions that we received, I could tell, it was a great, very well received webinar. So thank you very much.
Thank you for inviting us. And just for the audience knowledge, we will definitely get back to you on these questions that were a lot more questions asked, good questions, which we will get back to you.
Yeah, okay, great. And also do want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.
Thank you.